Okay, today we're going to do guided notes on the law of cosines. So previously we talked about the law of sines, ways of solving oblique triangles, meaning non-right triangles, using either the sine ratio or the cosine ratio. And remember, the sine ratio and cosine ratio, trig ratios, they're really meant for right triangles. And now I'm talking about a non-right triangle. So it's a different formula. It's not just the ratio of the side lengths that we're looking at, but it is a ratio that we still use. So look at the previous videos on the law of sines. This video we're going to focus on the law of cosines. Now we use the law of cosines in very specific situations. So here's the law of cosines, and when do we use them? We use the law of cosines when we are given a situation like side, angle, side. So if I'm given two sides, like side B and side C, and I'm given side A, or angle A, sorry, this would be side, angle, side. You might remember that from when talking about proving triangles congruent. However, we can also use the law of cosines when we're given all three side lengths. See, these are two situations when you cannot use the law of sines, and so this is another way that we can solve triangles. And to solve a triangle means to find all of the missing angle and side lengths. Okay, so what does the law of cosines look like? The law of cosines is really a pretty simple formula, and it simply states this. Sorry, let me make sure I get this so we can see it. I'll make it just a little bit bigger here. Here we go, okay. And it's still not where I want it. Okay, here we go. So here's what we're looking at. We're looking at the side length squared, and that's going to be equal to the sum of the other two side lengths, or the sum of the square of the other two side lengths. Whoops, I forgot to add. Did you see that? Okay, so I'm going to square that minus the product of 2 times each of those side lengths times the cosine of that angle that is opposite the side on the other side of the equation. Let's make this a little bit bigger so it's maybe a little bit easier for us to read this formula. So again, here's what we're doing. We're taking a side length and we're going to square it, and it's equal to the sum of the other two side lengths, each squared, minus the product of those two sides times -2 times the cosine of the angle that's opposite the side, right? So it's a lot of words. You might see the Pythagorean theorem in here a little bit, right? So you might see the quadratic formula in here a little bit, right? These are all part of the same kind of formula, right? So now, why do we have 2 more bullet points? Well, because we can rewrite this equation in several ways, right? So in other words, we're always relating a side length and the cosine of the angle opposite it. So let's go ahead and type in the other 2 equations. So the other one would be, what if I'm given side B, right, or I'm finding side B, so B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of angle B. And again, let's move this where we can read that a little bit easier, right? And so I've got the A squared one, I've got the B squared one. Well, what about the C squared one? Okay, so I have this formula also, and it says that C squared is equal to A squared plus B squared minus 2AB times the cosine of angle C, right? So all 3 of them are really the same formula. So if you remember one of these 3 formulas, you've got the rest of it down. All right, so then let's talk about how do we use the formula. So let's take a look at example 1. Example 1, it's asking us to find the missing angle measure. So here's the angle we're going to find, right? Let's go ahead. Sorry, it's not asking us to find an angle measure. It's asking us to find a side length. And it's asking us to round our answer to the nearest tenth. So we want to make sure that we're going to round our answer to the nearest tenth, 1 decimal place. All right, so here's what we have. We don't have anything labeled. So the first thing you might want to do, if it helps your own sensibilities, is go ahead and label the angles. So I'll call this angle A. I'll call this angle up here angle B, and the one down here C. And then label your sides. Remember the side opposite angle A, that's our side little a. The side opposite angle B is our side little b. And the side opposite angle C is our side little c. Now that I've labeled them, it makes it easy. And notice I labeled them to match the first equation, right? So I have the information that I'm looking for and the information that I'm given. So now I know that x squared equals, so it equals the other two sides, the sum of the square of the other two sides. In other words, it equals 23 squared plus 9 squared minus 2 times 23 times 9 times the cosine of 71 degrees. Okay, now I can, whoops, I forgot to put the square for that 9, right? 23 squared plus 9 squared, can't forget the square. So now I can simplify this a little bit. I have x squared is equal to, I'm going to type in my calculator my 23 squared plus my 9 squared, and that is equal to 610. Now, be very careful. I see this all the time. Students then want to take the, subtract the 2 times 23 times 9. They want to subtract that from 610. You can't do that because this is all grouped together by multiplication. But I can simplify the negative 2 times 23 times 9. So I'm going to do that. 2 times 23 times 9. That's my 414. But this is 414 times the cosine of 71 degrees. So this is as much as I can simplify this equation without rounding numbers. And I don't want to round into the very end. So I do have a couple of options. Option 1 is simply take the square root of both sides of the equation just as it is. So I have that 610, the square root of 610 minus 414. Oh, sorry about that handwriting there. 414 times the cosine of 71 degrees. Okay, so that's actually what I'm going to type into my calculator right now. So I have my second, and then the x squared button, that gets me my square root. 610 minus 414 cosine 71 degrees. I like to come out of my square root before I hit enter, but you don't have to. It's just my sensibilities. Then again, I'm asked to round to the nearest tenth. So I have 21.799, this 9 in the hundredths place. It's going to round to the 7 in the tenths place up to an 8. So I get that x is approximately 21.8, whatever my units are. Feet, inches, centimeters, meters, I don't know because I wasn't given the units this time. So I'm just going to put UN for units here. Now, remember I did say that there was another way you could put this in your calculator. Some students really prefer to simplify the radicand before they put in the square root. So in other words, there are many students who would want to do the 610 minus 414 cosine 71 degrees. And they want to simplify that first, right? And I can understand that. We need the square root of that, and we don't want to round until the absolute end. So in other words, I don't want to round this to 2 and find the square root of 475.2. I want the square root of this whole thing. So to do that, I'm going to take the second and the x squared button, and then I'm going to use that second button again, and the negative button. That's going to take the answer here and put it in my square root. So when I click enter again, you can see I get the 29.799 that I had before. So this is just a way I wanted to double check, make sure that you understand there are 2 different ways that you can get that answer. I'm going to stop this video here, come back for the next video, and I'm going to do example number 2 from our guided notes.